Bonjour. This is the second video in the introduction to probability chapter, and in this video, which I think will be a little long, I will be concentrating on two terms that are fundamental to probability. So let's start with the first of them, that is in French issue, and in English outcome. So let's look at the definition. Une issue est un résultat possible d'une expérience ou d'un essai. In English, an outcome is a possible result of an experiment or trial. So let's take the most simple experiment that we have done, that is tossing a coin. So a coin toss can have two outcomes. It can either be heads or it can be tails. So each one of those possible results, heads and tails, is an outcome. So when you toss a coin, you can have only two outcomes. En français, deux issues. When you toss a coin, heads is called pile. No. I forget what these terms are in French. Heads and tails. Pile et face. I think pile is tails and face is heads. Anyway, so this is a very, very important concept. Later on, we will come to what is known as a probability tree. We'll do that in the next video. In fact, if you look at the book on page 68, you will see here, this is called the probability tree. Are des issues pondérées par les probabilités. This is the probability tree, and we will look at this in the next video. Okay, so let's just take a few more examples. This is the one I said, tossing a coin, two possible outcomes, H or T. Throwing a die, now I've even drawn one, six possible outcomes, 1, 2, 3, 4, 5 or 6, correct? You'll only have any one of these six outcomes. You cannot have anything different. So it's when you throw a die, you can have only six possible outcomes. So let's take another example. If I have a wheel, a pinwheel with a pin through the center, and I spin it, and there's a marker, and wherever it stops is the outcome. So then this has got 8 divisions and 8 numbers. So here total issues, issue total sont égales à 8, qui sont 1, 2, 3, 4, 5, 6 et 8. So when you have a wheel like this and you spin it, you will get 8 possible outcomes. Let's take a slight variation of that same wheel. Again, there are 8 possible outcomes, because there are 8 divisions, and when you spin it, wherever the quadrant in front of the what do you call it, the pizza slice, let's call it, in front of the marker is the outcome. So here you have again issue total with 1, 2, 3, 4, 5 et 6. So here it doesn't go to 8 because the 2 is in 3 of these arcs. So you get 8 total issues, but issue unique only C's, that is 1, 2, 3, 4, 5, 6. So this is slightly different. Total issues, total outcomes 8, unique outcomes 6. So you have total outcomes are 8 because the wheel can stop in 8 different positions, and here you have different outcomes can only be 6 because 1, 2, 3, 4, 5 and 6 are the only numbers that are there on this wheel. So you have to realize that when they ask how many issues are possible, sometimes they might be asking issue total, and sometimes they might be asking issue unique. In this book, in TM3, they usually, when they say issue, they usually mean issue unique. That means different possible results. Okay. So this is the first concept that we are going to, first term that is part of this part of probability. But you never, now when you calculate the probability, you can say what is the probability of, when we spin this wheel, of getting 6 as a result, as an outcome. So probability is never calculated for an outcome. Probability is calculated for an event. And event and issues, or rather in English, event and outcomes, are slightly different. Okay, so next topic is événement, event. If you go back to the book, here you'll see notion de événement. They start with defining what is an événement, and then they talk of a probability d'un probabilité d'un événement. They don't even talk of probability d'une issue. They only talk of probability of an event. So when you calculate probabilities, you only calculate probabilities for events, not of outcomes. So what is an event? It's very simple. It is a set of outcomes that we are interested in. So an event can consist of one or more issues. So that, or an event can be made up of one or more issues in a particular experiment or trial. So let's take, I know this is a little confusing, but let's take examples. Let's take case of a die. That means we have 6 unique total issues and we have 6 unique issues. I should not be mixing English and French. So in the case of a die, you have 6 total 6 total outcomes and 6 different outcomes, because in the case of a die, each of the faces is numbered differently, 1 to 6. Okay, so we can define event A that throw equals 3. So we are defining an event where a throw we get 3. So the outcome that satisfies that makes up this event is when the result is 3. We can say event B, we can define another event when the throw is pair. So remember, when I say throw is pair, 1, 2, 3, 4, 5, 6, the word pair is not there, but the pair, this event is satisfied by outcomes 2, 4 and 6. So 3 of these different outcomes or unique outcomes will make up event B. Throw is pair. Similarly, if I had said throw is pair or throw is odd, then issues 1, 3 and 5 would make up event B. Event C, throw is less than 3. In this case, only 2 issues, only deux issues, un et deux, constitueront événement C. Only outcomes 1 and 2 will make up events C. Event D, let's define a fourth one, throw equals 7. So no outcome will satisfy event D, because on a die there is no number 7. So this is, so you can think of an event as a combination of one or more outcomes. Here you saw it was event A was equal to outcome 3. Here event B is equal, throw is pair is equal to outcomes 2, 4 and 6. So in this case event B is made up of 3 outcomes. Event C here is made up of 2 outcomes, and event D here is made up of no outcomes. Okay. So now what you do is you can calculate the probability of A, probability of B, probability of C and probability of D. because as I said, probability is only calculated or only applicable for events, not for outcomes. If you want for outcomes, then you have to define one event that corresponds only to that single outcome, like here throw equals 3. Then you can calculate the probability of event A in this case. Okay. So probability is always measured for events, not outcomes. And how do you measure how do you measure the probability? So probability is written like this: P of A is the name of event, here like name of the event A and total outcomes. This is the definition of probability, event A over total outcomes, which is outcomes that make up event A divided by total outcomes. So let's take this case, throw equals 3. So how many outcomes satisfy this event? Only one, so you'll put 1 on top. How many total outcomes are there? And when we say total outcomes, we have to look at issue total, not issue unique. And in this case, the numerator is 1 and the denominator is 6. Total outcomes are 6. We are talking of a die. So in this case, a probability that you will roll a 3, your throw will equal 3 is 1 over 6, which we know because a die, assuming it is properly balanced, will give you a 1 in 6 chance of getting any one of the 6 numbers on it. Okay, so let's take the example of a coin toss. So probability of a coin toss. So say event H, I define event H as heads, then P of H is equal to 1 over 2, because 1 is the outcome that makes up event H. Only one outcome makes up event H, that is the heads, and 2 is the total number of outcomes. You can only have heads or you can have tails. So you only 1 and 2. So you have 1 over 2. So that is why P of H is equal to 0.5. The probability of getting heads, of satisfying this event, which is defined as heads, is 0.5. Similarly, P of T is also 0.5, where T is event T of getting tails. Let's take a few other examples. We say die throw. Again, we're going back to our die throw, and here I'm defining it. Event A is if the throw equals 1, then P of A is equal to 1 over 6. That we already looked. So 1 over 6 is around 0.1666, or I've rounded it to 0.167. Okay, let's take event B, throw is pair. So how many outcomes make up event B? You have 2, you have 4, you have 6. So 3 outcomes make up event B. So you'll get P, probability of B, P of B is, this is also like a function, no? The probability function for input B, where the input is the event. So here you get 3 over 6, you'll get 0.5. So whenever you throw a die, you have 50% chance of getting a pair number, which is intuitively correct, we know, because half the numbers are pair, so half the chance of getting a pair number. Okay, so let's say if we have event C, throw is less than 3, then only outcomes 1 and 2 will make up event C. So you have only 2 events out of a total of 2 outcomes out of a total of 6 outcomes, and you get 0.3333. So probability of this event is 1/3. And then let's take that event D, throw is equal to 7. So no outcome will make up event D. So 0 outcome. So P of D is 0 over 6 is 0. So probability of getting a 7 when you throw a die is 0, which again is very intuitive. And let's take another case. Event E, throw is less than or equal to 6. Now, how many outcomes satisfy this event? How many outcomes satisfy, how many outcomes make up this event? Well, actually all of them. 1 is less than 6, 2 is less than 6, 3 is less than 6, 4 is less than 6, 5 is less than 6, and 6 is equal to 6. So in this case, the probability of event E, 6 over 6, is 1, which means it is a totally, it's a certain outcome. So if somebody says, what is the probability of getting 1, 2, 3, 4, 5 or 6 when you throw a die? The answer is the probability is 100%. You will 100% get one of those numbers. Okay, so now we can come to certain descriptive terms. One is event is called impossible, impossible, if p is equal to 0. Event is called certain if p is equal to 1. So this event is certain. Un événement certain. Un événement certain. Singular, masculine. Okay, event is certain if p is equal to 1. So if we go back to my examples from the last video, what is the probability that Kimda will win gold medal in the 100 meters in the Olympic Games? Probability is 0, so that event is impossible. What is the probability that Kimda will eat some food today? That is absolutely going to happen, so that event is certain. Okay. Two events are incompatible if they cannot occur at the same time. Example, in a throw of die, if I say event A is throw is pair and event B is throw is equal to 5, then events A and B cannot happen at the same time. You cannot throw 5 and as well and have it as a pair at the same time. So you will say events A and B are incompatible. Événements A et B sont incompatibles. Okay. Oh, this video is shorter than I thought it would be. Anyway, so two events are complementary. In French, better word, contraire. Two events are complementary when one is the opposite of another. So event A, again we are taking the case of a die. Event A, throw is equal to 1. Event B, throw is not equal to 1. So this one's probability is 1 over 6. This one's probability is 5 over 6. These are called complementary events or événement contraire. And there is a special way of writing événement contraire or complementary event. B is equal to A, and there is a little bar on top which indicates the complement, that means the opposite. So P of A plus P of A bar is 1 always. Here we saw 1, this one probability of A is 1 over 6, probability of B is 5 over 6. If you add those two up, 1 over 6 plus 5 over 6, you will get 1 always. Always. So if I say it in a coin toss, what's the probability of getting heads? That is 0.5. What is the probability of not getting heads? That is also 0.5. When you add that up, you will get 1. Okay. So indeed, we will stop here. I will give you one in-video problem. So here it is. So I have a bag in which I have 8 tokens numbered 1, 2, 3, 4, 5, 6, 7, 8, and without looking I put my hand in and take out one token. So list outcomes that satisfy the following events. E1, multiple of 3. So this one I'll do for you. So the answer for this one is multiple of 3. There are only two numbers that are multiples of 3. So the outcomes that make up E1 are 2 and 6. Sorry, 3 and 6. 3 and 6, these are the only two numbers that are multiples of 3. So similarly, you write E2 where number is greater than 4, number is greater or equal to 4, and E3 a pair number greater than or equal to 4. So you do these two, you can even do the first one even though I told you what it is. And then you have to calculate P of E1, probability of event 1, probability of event 2 and probability of event 3. This is the in-video problem. In the next video, we will take up the probability tree. Okay, I will stop here and you send this to me to prove that you have understood and you have watched the video.